Everyone, welcome to this video where we are given ABCD is a vertically upright rectangular soccer goal post, so it is vertical, and there is a horizontal field ABP. Okay, so this is important. Once we know that there is a vertical plane and a horizontal plane with the respective information given, find the area of triangle ABP. Okay, so for part A, right, if we were to look at the triangle ABP, which I'm going to just simply sketch this out. So for part A, I would then have this triangle A, B, and P. And I know this is 63 degrees. And being a rectangular goalpost, I would also know the length of AB, 7.32 meter. Now, if I somehow is able to find PB, then using the formula half AB sine C, I would then be able to find the area of triangle ABP, since I already have the angle here and one of the other length down there, 7.32. So right now, the question is, how do I get this PB? This is where I go back to the question, and I saw this, where they give me the angle of elevation of C from P, and so to make it easier for us, then I shall redraw this into the and this is a 90-degree right angle triangle. Why? Because BC is vertical, BP is horizontal ground, and so I will have 15 degrees here, and this is given as 2.44 meter. So using Tuakaso, I would be able to get the length of BP, and after which I can then find the area of the triangle for part A. Okay, so that will be the first part, where then applying Tuakaso for angle 15 degrees, this is my adjacent side, opposite side, with O and A, and given Tuakaso, yes, I'm choosing tangent. 15 degrees is equals to opposite over adjacent side. So from here, I would then be able to get my PB, which is 2.44 dividing by tangent 15 degrees to give me a value of 9.1062 to 5 SF. This one is meter, 5 SF. Then, now that I know this is 9.1062, I can then apply my area of triangle. Yeah? So area of a triangle, in this case, ABP, would then be equal to half times 7.32 times 9.1062 times the sine of 63 degrees. And then this will give me 29.696 to about 5 significant figure. 29.7 meter square, 3SF. Alright. Now, for part B, the shortest distance of P to the goalpost. In this case, we are looking at the perpendicular distance. So, I am going to indicate here 90 degrees. So this is where the shortest distance is, and I'm going to call the shortest distance X. Okay, so at this point, right, then for part B, I'm going to do it here. I'm going to just redraw triangle ABP, sketch it out so that it's initial, and then this will be my X. Okay, and I already know certain information. Already know the area of this triangle from part A, right? And because I also know AB, and so using that idea, the area of triangle ABP is half times 7.32 base times height X. This is the base and this is the height, and we also know the area of this triangle, 29.696. This is from part A. And from here, I can then find my X easily. So X, again, of course, do let people know, let X be the shortest distance from P to the goalpost. So people know. Okay? Then my X will therefore be equals to 29.696. I'm going to divide by half, put a bracket, divide by 732. This will give me 8.1137 to about 5 significant figure. 8.11 meter, 3SF. Alright, so we are done with part A and part B. Part C, find the length of AP. So I'm going to duplicate this triangle. Lucky. I'm glad I draw this, because then I could easily tap on this for my part C then, which I'm going to do it here. Find the length of AP. I got 7.32. I've got the angle 63 degree. I also got this length. What rule do you think we should use? Brilliant! Cosine rule. So my AP is therefore equals to 7.32 square plus 9.1062 square minus 2 times 7.32 is 9.1062 cosine 63 degree square root. This will give me a value of 8.7167 to about 5 significant figure, 8.72 meter to 3SF. And for part D, where we will need to find the angle of elevation of D from P, we would then need to look at this right angle triangle here, which I'm going to draw DAP. Okay, so for part D, DAP, I already know this is 2.44 meter because it is a rectangle. I also know my AP, 8.7167 meter, and the angle of elevation we are looking at is this. So with respect to the angle, this will be my adjacent side, opposite side, and given tuakaso. Which of these trigonometric ratios should I use? Yes, O and A, tangent. Opposite, oval, adjacent. So my angle DPA is the tangent inverse of this. And this will be a value of 15.638. 5 significant figure, 15.6 degrees to 1 decimal place, and therefore the angle, we do need to give a nice presentation, okay? The angle of elevation of D from P would therefore be equals to 15.6 degrees. And with that, we have come to the end of this video. So if you like this video, do give it a thumbs up. Thank you for watching and have a nice day.